Okay, guys, this is an additional question on fuels and heats reactions. If we look at this one, write a balanced chemical equation for the combustion of ethanol, C2H5OH. Where you look at this family of compounds again, this is an alcohol family of compounds, and this is one of them, ethanol. Given that the heats of formation of ethanol, carbon dioxide and water are that, and that, respectively, calculate the combustion of ethanol. So the first thing I would do is realise that this is a hydrocarbon with some oxygen in it as well, hydrocarbonate, but in any case, when you burn these, it's the same products as when you burn a hydrocarbon. So essentially you need oxygen, which is the other reactant, and then the products are the same, carbon dioxide and water. Then we just need to balance this equation, if you like. There's two carbons there, so we better put a 2 there so that there's two carbons now on that side, because there's only one carbon and that's CO2. But if I have two of them, then I'll have 2 in total. Once I have that done, then I would always leave the oxygen to the last because it's on its own. So you have one oxygen in that molecule, and then you have 2 oxygens there, which gives you 3. Over on this side you have 2 times 2, which is 4, and 1 is 5. So we have 5 there. So essentially we need to try and find the LCM of the two of these. So you have 2. Well, perhaps if you brought this up to 3, then you would have 2 times 2, which is 4, and 3 is 7 there. And then if you put in number 3 there, then that will allow you to have the same number of oxygens. 3 times 2 is 6, and 1 is 7, because there's 1 in one of those. 2 times 2 is 4, and then 3 times 1 is 3, so you bring it up to 7 there. Then the next part is to calculate. It says, given the heat summation, calculate the heat of combustion of ethanol. So to do that, you write your formula, delta H of, in this case, HC. That's the type of reaction it is, a combustion reaction. The sum of the heats of formation of the products multiplied by their coefficient minus the sum of the heats of formation of the reactants. So remember, it's always the products minus the reactants. That'll give you the correct sign for delta HC. So we don't know delta HC, so we'll just put that in as that. The sum of the heats of formation. Now you just need to be careful here. You see how it's written. Given the heats of formation of ethanol is that one. Carbon dioxide is that one. And water is that one. You wouldn't believe the number of people who makes mistakes in that. So the products here are carbon dioxide. So CO2, if we follow that one across, and that will give you minus 394, and don't forget to multiply that by its coefficient, so important, plus 3 times, it's a coefficient of 3, you see, waters, it says the carbon dioxide and water, so that water over there, minus 286, minus the sum of heats of formation of the reactants, which in this case is 1 times C2H5OH, which is minus 278, and plus 3 times oxygen on its own. Anything on its own is 0. I'll give you delta HC is equal to, and we can just use our calculator for that. So we can multiply that, 394 multiplied by 2, and that'll give you minus 788, and then 3 times that will give you minus 858. Do that in your calculator, and then minus, remember that's a negative in there, so a minus, and you can put that in the bracket there, 278, minus 278, 1 times minus, and 3 times 0 is obviously still 0. You could keep that square bracket there, and then delta HC is equal to, you could add the two of those, adding the two of those together carefully, So that's 788 minus 858. And then you would be minus 858. So that will give you 1646 minus, and then you could multiply in that minus, and that will give you plus 278, and then delta HC. You just need to add these two together. That minus by a minus there is a positive, obviously, that's why that's a plus. And then you could add that, and that's 278, and that brings you back to minus 1368. And there you have it. There's the heat of combustion of ethanol, and a balanced equation written as well.